SAHNE, self-serving assets in a highly networked environment. A software architecture project by the Distributed Information and Automation Lab at the Institute for Manufacturing, University of Cambridge, UK, for the Boeing Corporation. If parts on an aircraft had intelligence and could communicate, what might they usefully say? If they had the ability to sense their immediate environment and could assess their status and make individual and collective decisions about their future, if they could communicate over the web, they could organise and authorise their own repair or replacement, or even their refurbishment for reuse on another aircraft.
The SAHNE project was born as the result of the Strategic Technology Development Partnership between Boeing and Cambridge. Cambridge researchers accomplished the challenging tasks of automating the identification of part replacement requirements and then automating the part procurement process itself. The results of this project form a foundation upon which our supply chain experts will build and will guide our development in supply chain automation for some time to come.
Boeing wanted to use microprocessors attached to aircraft parts that would know their own expiry date, communicate with each other and come up with a collective reorder of replacements automatically. With applicability to all commercial aircraft, this was the research challenge. Dial suggested an alternative which would reduce the hardware issues with part-to-part communication. Based on each part having a unique identity, they decided to allow the components to interact in a virtual world. Each component would be represented by a software agent, which would cooperate autonomously in this community. Other software agents would represent communities of identical components, for example, life jackets. SAHNE holds data on parts of an aircraft in a configuration database. It also has information on the condition of the parts held in another database. A third database contains the maintenance and overhaul schedules for all parts. Each component, such as a life jacket, is uniquely identified and has its own intelligent software agent. For each type of component, there is a software agent that looks after that community of components, called the community manager. The individual components check the condition database periodically to see if they need repair or replacement. If they do, they communicate this need to the community manager. The community manager checks with the other components of the same type to see if any are close to needing replacement or repair so that a batch order can be generated. Other life jackets check with the condition database. If they have a near-term replacement need and if the answer is yes, they signal this to the community manager. They are then able to join the order, increasing the batch size and thus reducing costs. A new software agent now comes into play. This agent, known as the Yellow Page agent, acts as the link to find potential suppliers for the community manager. For instance, I'm looking for life jacket suppliers. I will find suitable suppliers for you. Here is my request for a proposal. Suppliers, also represented by their own agents, then respond to this request. The community manager issues a preliminary contract, and the supplier agent is free to accept or reject the contract. Should more than one supplier respond, or should there be requests for the same thing from more than one community manager, a competition alert is raised. This brings into play an auction agent that can run a number of different types of auction depending on the situation. Finally, a contract and price is agreed and a new life jacket is sourced. The community manager acknowledges the arrival of the new part and creates a new agent for the new life jacket and updates the relevant databases. It seems obvious that these ideas could be extended to cover all routable parts. The implications for parts management and fleet configuration control are obvious. The SAHNE platform has been demonstrated with in excess of 4,500 agents making calls on suppliers at any one time. At the highest density of demand, orders were automatically placed within 7 minutes.
If you look in the academic or industrial literature to date, there are very few industrial strength deployments of technologies such as intelligent agents. And this was an opportunity for us to get involved in a project that from the very outset had its intent to deploy and disseminate these sort of technologies within a very large industrial organisation.